So we're going to do this problem number 8, where a football kicker lines up to kick a game-winning kick. The goalpost is 30 meters away. The ball must clear a 3.3 high crossbar. If the kick leaves his foot at an angle of 35 degrees, how fast must the kick be to be good, assuming no one blocks it? So let's draw a picture of our scenario. We're looking for this V, and they give us an angle. Just want to make sure that, yeah, it's in the video. So, as we mentioned, anytime we have one of these problems at an angle, we want to go ahead and split it into its components. So this is going to be V cosine of the angle, and this is going to be V sine of the angle. You write down the stuff that you know. Here's my horizontal. Here's my vertical. I know my horizontal velocity is equal to V cosine of the angle. In this case, the angle is 35 degrees. And my initial velocity upwards is V sine of 35. I also know my change of x. My change of x is equal to 30 meters. Change of x equals 30 meters. My change of y is equals to 3.3. And that's all I know. I don't know the fun. I can't say if VF equals 0 at the top because I don't know where this is in the trajectory. It might be on the way up, it might be at the top, or it might be already coming down. So I don't know anything VF over here. I know my acceleration is going to be negative 9.8. But that's it. What I can do, I can solve for the time over here. Because I know that V equals the change of x over time. So I know from this equation that my velocity, my horizontal velocity equals V cosine of the angle equals my change of x over time. I cross multiply, and I end up getting that my time is equal to change of x over my velocity, V cosine of the angle. That's my time. So my time is equal to change of x over V cosine of 30. And I know my change of x is 30. Sorry for the mess. 30 divided. My time going forward is going to be equal to my time in this direction, so that equals 30 over V cosine of the angle. And what do I ultimately want to solve? The V. So I want to solve for this V. So now I know time, I know I know my acceleration, I know all of these, and only one equation has all of that. That's going to be change in y equals VIT plus 1/2 AT squared. I'm going to plug in the things I know. So I know my change in y I know my V cosine, my VI is V sine of the angle times my time, and my time equals to my change of x over V cosine of the angle. That's my time. That's what I saw for my time. Plus 1/2 g, because that's my acceleration, and my time again. Change of x over V cosine of the angle. So I plug in, I want to get V by itself. So now I start multiplying. And the values that you plug in are right here. This is going to be 3.3. That's 9.8. So then I go ahead and I solve across. So I'm going to multiply. I'm going to simplify right here. So there's like an imaginary 1 right here. So I can just multiply across and I get V sine of the angle times change of x all over V cosine of the angle equals, plus 1/2 g. I distribute that square, so it becomes change of x squared over V squared cosine of the angle squared. So what I did, I multiplied this part out. I multiplied the VI times the T, and I went ahead and did that. There's a trig function where it says tangent of the angle is equal to sine of the angle over cosine of the angle. So if I see that in any math problem, I can go ahead and plug in this, which is what I'm going to do over here right now. So I get change of y equals change of x. This right here becomes tangent of the angle plus, again, I multiply across. There's like a little invisible 1 over the g. So I multiply all the top stuff and I get g change of x squared over 2 v squared cosine of the angle squared. And this is a negative g, I forgot about that. So now I'm trying to solve for v, don't forget that. I'm trying to solve for v. So now I'm going to go ahead and move all this stuff to the right. And the way I'm going to do that is I'm going to subtract this since it's being added to this side. So I get change of y minus change of x tangent of the angle. That gets subtracted. What I do to one side, I do to the other side. That goes away. So minus change of x tangent of theta. And that's going to equal my negative g change of x squared over 2v squared cosine of the angle. Sorry, I had to step out for a board. Because we're out of space here. So I have change of y minus change of x tan of theta equals, God, I need another whiteboard. Sorry, you're gonna have to fast forward this part. So I have change of y. Yeah, yes, it's there. Change of y minus change of x tangent of the angle equals negative g change of x squared over 2v squared cosine of the angle. So I want to solve for that. So I'm going to, if I want to solve for the denominator, I'm going to cross multiply, and these are going to switch places. So I end up getting, ultimately, I get 2v squared cosine of the angle equals negative g change of x squared over y minus change of x tangent of theta. I want to get b by itself, so I'm going to divide. I'm going to divide by 2. I'm going to divide by cosine the angle. This cancels out, and this becomes 2 over cosine, and I have a square root left, so I'm going to plug that in. So I take the square root over here, take the square root over there, becomes v equals the square root of negative g change of x over squared over change of y minus change of x times tangent of 0 all over 2 cosine of the angle. I can simplify that further. Here's the key, guys, right here. You skipped all that to right here. Here it is. I simplify equals g change of x squared over 2 cosine squared. 2 cosine squared change of x tangent minus change in y. So this is the answer. This is how you get the velocity. So to recap, g is my gravity, change of x is the horizontal distance they gave me in the problem, 2 cosine the angle which they gave me in the problem. So I know this number, I know that number because they gave me the problem, I know that number. Change of x, I know that number, they gave me the problem. Tangent, I know the angle, and I know the height they gave me the problem. So all I need to do is, I solved it with variables, but this is how you find the velocity of any problem that they give you the angle and you're looking for this velocity. That's all they give you. So if I had any problem where I know how far it is, I know the height, and I'm looking for the velocity and I know the angle, this is the general equation. I plug in my change of x here, plug in my angle here, my change of x here, my angle here, and I plug in my whatever height they give me there, and I can solve any problem. So this huge walkthrough was to solve the problem number 8, the football problem, which is similar to other problems that